Hello Bobcats. In this video we will discuss significant figures. To start out, we need to understand that measured numbers involve some estimation. In other words, remember we discussed earlier that there's always uncertainty in measurement. Okay, so significant figures ensure consistent reporting or recording of measurements based on the instrument used. Okay, so and also significant figures also that's in there. Significant figures also give information about the precision of the instrument. So that also gives information about the precision of your instrument. Being used to measure. Okay, now, so let's just kind of make a statement here. In that, we'll state that the number of significant figures in a measured value is equal to the number of known digits and plus one uncertain digit. And we've seen this definition earlier when we were talking about uncertainty of measurements. I misspelled that. It's A-I-N. Uncertain digit. Okay? Or the estimated digit, if you want to say that. Now, so to count the number of significant figures, in other words, if we were just to see a significant figure or a number on a paper or in an article or something like that, to count, there are rules to count the number of significant figures. So to count the number of significant digits or significant figures, if you want to say that, represented in a measurement we follow two basic rules. Okay, so rule number one is that if the digit is not a 0, in other words 1 through 9, it is significant. Rule 2. If the digit is a 0, it is significant. If A, it is a sandwiched 0, or B, it terminates a number or in other words follows a number, it terminates a number containing a decimal. So those are the two basic rules, and they're very simple to follow, and so we're going to go through some examples real quick to understand what we're talking about. Okay, so if I have a number, let's say 72.3, and I'm going to put a unit because we don't put numbers without units, but if I have this value, it says up here, if the digit is not a 0, it is significant. So all of these digits are not 0, so we have 3 sig figs, short for significant figures. Okay, so 1, 2, 3. Let's see if we have an 800.4 liters. Now, in this case, we have sandwiched 0. So here it says if the digit is a 0, so we've got some zeros here. We know that the 8 and 4 are significant because they're non-zeros. But if it is a 0, it is significant if it is sandwiched. And this is what we mean. We've got 2 zeros sandwiched between 2 digits that are significant. So that's 1, 2, 3, 4. That's 4 significant figures. Let's look at this example. If I have 1.200 and then say it's meters, we have a decimal. So let's look at the rule. If the digit is a 0, so we have zeros. Now we know the 1 and 2 are significant, but if the digit is a 0, it is significant if it terminating, so it's at the end here, a number containing a decimal. So here we have a decimal, so now those zeros are significant. So we have 4 significant figures again. Now let me discuss this for just a minute also, in that I said that it gives us information about the precision of the instrument. So here we know that this last digit is the estimated digit, and we know, therefore we know that the precision of this measurement is to the 10th of a gram. This one's the estimated digit here, so we know that the precision is to the 10th of a liter. Here our last digit is in the 1/100,000th place, so we know that the precision of this measurement is to the 1,000th of a meter, because it is, that 0 is significant. It is telling us that we can measure as small as 1,000th of a meter. So it's a very important 0. Let's continue. So I'm going to go to a next page, or actually let's try to get some more examples on this page. So if I look at this page again, so let's look at what if I have a number like 1500, and let's say that's 1,500 milliliters. Now, in this case, we have terminating zeros, but there is no decimal. And if there is no decimal, those zeros are not significant. So the only significant numbers are the 1 and the 5. So we have 2 sig figs here. If I continue with this, let's look at a number like 0.00750 seconds. Now we got to figure out how many significant figures here. Now we do have a decimal, but the only time a 0 is significant is if it's sandwiched between numbers or if it terminates a number. Now, so these zeros up here, these 3 zeros in front, are not terminating a number. So they are not significant. This 0 does terminate the number, so it is significant. So these are all 3 significant. So we have, in this case, we have 3 significant figures. And it's as simple as that. Now the reason we call these zeros here they are placeholders, because they're holding that place. They don't tell us much, but they hold the place. These 2 zeros are also placeholders. When I look at this and I wanted to see what kind of precision we have, I'm going to look at that number, and that means that the precision of this measurement is the 100 mils. So 100, 200, 300, 400, 500 mils. That's my precision. Here we say that the precision is that 0 because it's significant, and so the precision of this is tens, hundreds, thousands, 10,000s, 100,000th of a marking measurement. Okay, so that is significant to the 100,000th place. Now, if you're having difficulty really understanding how come there's only 3 here, if you write this as a fraction, you would write it as, so let me write it in fraction form. It would be written as 750 over 100,000. So you can tell right away that we have 1, 2, 3 significant figures. You don't write it as 00750 over 100,000, you just write it as 750. So when I convert this to fraction form, you can see easier why that's just 3 significant figures. So now let's look at the math involved, or rules in mathematical operations with significant figures. So let me write that down. So the next idea is rules for significant figures, and I'm just going to write sig figs because that's short for significant figures. But the rules for significant figures when doing mathematical operations or math operations. Let's just say math operations. Okay, so let's look at the rules for math operations. The first rule I want to discuss is if we are looking at addition or subtraction. So if we have to do addition or subtraction, what we have, the rule is this. Significant figures or sig figs for an answer is determined by the least precise measurement. Is determined by the least precise measurement. Now, your textbook and many other sources will say that the rule is the least number of decimal places. But you'll understand why I don't use that in just a minute, and why I decided to use least precise measurement in this rule. So if I take, and I'm going to add Let me use a different color so we know we're doing the problem. So if I add 3.465 grams plus 24.3 grams, what would that equal? Now, you first go ahead and you do the calculation. So on a calculator you do it, or you can do it by hand, whatever. You would write 27.765 grams. Now we have to determine how many sig figs we should have in this number or this answer. Well, if I look at this, we see that this has a precision to the 1,000th place, and this has a precision to the 10th of a gram. So our answer can only be based on the least precise, which is a 1/10 of a gram. So the answer has to stop at this digit. So, and we would need to round it up. So we would write as an answer 27 point, the 6 rounds the 7 up, 27.8 grams. And so that answer is based on the least precise measurement in the addition problem. Let's look at a subtraction. Now this is why, so this is good when we're looking at, we can say the least number of decimal places. But what if you had a number like this? So now let's subtract. Let's take 1,500 or 1,500 milliliters, and we're going to subtract 125 milliliters. There are no decimals involved. So how would you quickly determine how many significant figures there are? So in this case, the least precise, remember these zeros do not count, they're not significant, they're just placeholders because there's no decimal. So the precision is at the 100ths of a mil, 100 place. Over here, the precision is at the 1 place. So the least precise is at 100, so we would have to round to the 100ths place. Now when I give the answer, when I do this, I get 1,375 milliliters, but again, the least precise place is the 100ths place, so I would have to write the answer as 1,400 milliliters. So now you can understand why I say the least precise rather than the least number of decimal places. The next thing we want to look at is multiplication and division, or division. So B, multiplication or multiply or divide. I should say multiplication and division, but I wasn't paying attention. I wrote it as multiply, but multiply or divide, same thing. Those are mathematical operations. So if I'm going to multiply or divide something, then this is the rule. The rule is that significant figures, sig, figs, are determined for an answer is determined by the number with the least significant figures, by the number with the least significant figures. So what do I mean by that? This is different than addition subtraction. So when I take a number and we multiply it, if I take 123 meters times 46 meters, we get an answer of 5,658 meters squared. Now, So this has 3 sig figs. So when I look at this one, there's 3 sig figs here. And this one has 2 sig figs. Okay, so 3 and 2. And so our answer will have the least number of sig figs. So in this case, 2. So I can only show 2 sig figs here. So when I write this out, I would write it, the 5 rounds the 6 up, so I would write that as 5,700 meters squared. That has 2 significant figures. Now, I haven't mentioned this before, but we use scientific notation to help us write and show significant figures and clarify significant figures. Now, if I were to write this into scientific notation, the rule is that you have 1 digit to the left of a decimal, and then you would show the rest of the numbers would indicate the number of significant figures. Now, in this case, we would just say 5.7, and then there's 1, 2, 3. So if you assume that the decimal was here and we moved it over 3 places, that would be 5.7 times 10 to the 3rd meters squared. Now, the official way to write things in numbers in science is to use scientific notation, because it clarifies the number of significant figures, and scientific notation helps us when we are writing very, very large numbers or very, very small numbers. Now, very, very large numbers will have 10 to a positive exponent. Very, very small numbers will have 10 to a negative exponent. And I will discuss that a little bit more in just a minute. So now let's look at a division problem. So if I took, and I want to know the density of something, and I have 4.356 grams, and I divide that by 5.0 milliliters. Again, the top one has 4 sig figs, the bottom one has 2 sig figs, so my answer has to have the least number of sig figs. So in this case, 2. So real quick, I'll just write this up, write this to the side in different color. We had 4 sig figs up here, we had 2 sig figs down here, so I need to have an answer with 2. Now, of course, you go ahead and do it in the calculator. The calculator gives us this value. But remember, we only want 2 sig figs, so those are the 2 I'm going to look at. And so my answer is going to be 0.87 grams per milliliter. And so you can see how this is different than the least precise. We're looking at the least number of significant figures. Now, the next thing I need to do is go over some rules of what you do not use to determine significant figures. Or first, let's talk about math a little bit more. The next thing you need to understand, and I'll just write this as C, is that when doing multiple operations, math operations, you need to keep track of the number of significant figures in each operation. So when you're doing multiple math operations, keep track of sig figs as you do those operations. As you do the operations. Following PEMDAS. Using PEMDAS. So using, sorry, my paper keeps falling over. using, let me try this here, PIM, so that's parentheses, exponents, multiply, divide, add, subtract. So you follow your PIMDOS operations. Okay, so I need to give you an example of that, and I actually need to come up with one because I forgot to put it in my notes. So hopefully this will work out without too much trouble. I ran out of paper, so grab a piece of paper. And so if we do this, let's say I have a problem like this. Let's do 7.223 plus 9.14 plus 3.7795, and then we're going to divide that by 3.1. Now, so as I go along and do this, we would follow PIMDOS, and so when I add these three together, I get an answer of, and I need my calculator. So I add 7.223 plus 9.14 plus 3.7795, and this would then, that's the first step, so this would be, and remember we're going to determine, because this is addition, and the least precise is in the hundreds place, so the answer up here when I do this is going to be 20.14 as the number, and then again I'm going to go ahead and we're going to divide that by 3.1, and when we do the division, now we're going to look at the least number of significant figures. In this case we have 4, here we have 2, so my answer has to have 2. So I'm going to go 20 point, but we carry all the math all the way through. So yes, I had some values up here. The calculator actually gave me a number of 20.1425. So I'm going to use that number in my calculation, but I had to determine my number of sig figs as I go along. So that 20.1425 divided by 3.1, I only want 2 sig figs. Now my calculator gives me this big old number, or it kind of throws out everything. It doesn't know how to round off to sig figs. So this is what my calculator gives me, and I don't want all of that. I just want, remember we determined we had 4 here, 2 here, so my answer can only have 2 significant figures. So really what we would say is that the answer is 6.5. 2 significant figures, but you carry all of the numbers through, but keep track of the significant figures as you do each operation. Now the last thing for this video that I want to discuss is a couple of rules that you need to be aware of. The first one is that only measurements are used to determine significant figures. So if it's not a measurement, we don't use it to determine significant figures in the answer. Okay? Next, do not use what I call reference numbers or defined numbers. So don't or do not use reference numbers to determine sig figs. or defined numbers. In other words, and I'll write this down in just a second. So reference numbers or defined numbers to determine sig figs. In other words, an example of that would be, we know that 1 mile is equal to 5,280 feet. And so I would use neither one of these. I could not use any of these numbers to determine sig figs because they are defined, whereas I would need a measurement to determine significant figures. Another one is, never use fractions. We do not use fractions. So do not use fractions as an answer. And the reason is this. Because fractions are exact, while measurements have uncertainty. Now let me give you an example. If you use the fraction 1/3, well, 1/3 is an exact number. It's 0.3333 repeated. Whereas, and so that goes on forever. And so it doesn't tell us much about a measurement because measurements have uncertainty and you have to stop somewhere. You have to have a number of significant figures, whereas a fraction has significant figures that go on forever. So you don't use fractions. And then the other thing is, do not use counting of objects to determine sig figs. Because they're not measurements. So do not use counting to determine sig figs. So again, only measurements are used. Do not use reference numbers or defined numbers such as 1 mile is equal to 5,280. We do not use fractions because fractions are exact and they have infinite number of sig figs, and so they don't work as measurements, and we do not use counting of objects. And that is the end of my discussion on significant figures. Have a good day.